Hello again, this micro lecture is on electric and magnetic fields. As always, you need 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and do your follow-up questions on Google Forms. So let's review real fast. We looked at before this idea that your position in a gravitational field allows you to store energy. Namely, because there is a pull on this object over here, that pull can cause it to kind of increase its kinetic energy. So we say that energy is kind of stored in its position. The kind of ability for Earth to do work on this in the future based on gravity. Similarly, the position of a charge in an electric field, so if we place a charge here or we place a charge here, can allow it to, or can store energy based on its position. Now it's going to be a little different because we can have both attractive, in this case, or repulsive forces. It'll change up how you store energy, but ultimately, based on your position, you can store energy based on where you are in an electric field if something is charged. If it's not charged, then this won't do anything. And the same thing goes for the position of magnetic material in a magnetic field. So if we put something, let's say right here, that's a magnet, we can store energy because it's going to be attracted or repelled by this end of the magnet, and as a result, its position is allowing it to kind of maintain some energy level that could in the future be released. So in looking at gravity, we can store energy based on its position, and namely we do that by increasing the amount of distance increases the amount of energy stored, because it's got further that it could fall, or something along those lines. Now, that's true for attractive forces, but in a repulsive force, it's actually the opposite. So let's look at attractive forces first. So similarly, we can look at 2 charges that are oppositely charged, so they're attracted to each other, and 2 magnets where the opposite ends are facing each other, so there's an attraction there. And by pulling this magnet out further and pulling this charge out further, we've increased the amount of energy stored. The reason why is because it has further to kind of fall towards this charge and further to be pulled towards this magnet, where it will accelerate it and give it more kinetic energy, or whatever other type of energy you're going to convert that potential into. Now, the opposite is true for repulsive forces. So you actually decrease the distance in order to increase the energy. The reason why is think of it like compressing a spring. If these two are pushing each other apart, so in other words, they're kind of pushing off of each other, then you store more energy by bringing them closer together because there is more room for this guy to be flung out to the side. So in general, the way you can think about this is to store more energy in a field, you want to move in the direction that is opposite of the direction of the force. So if the force is pushing to the right, if the force is pushing to the left in this case, then we'd want to move our charge to the right in order to increase the energy. If the force on this magnet is pushing it to the left, then we'd move this magnet to the right or closer in order to store more energy. Whereas in the previous case, the force was pushing to the right, and so we move it to the left so to store more energy. That's it for this one. 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and do your follow-up questions on Google Forms.